Hello, everybody. I'm Lisa Rosenbaum, and I'm your Automotive Division um, webinar chair. The Automotive Division is a chapter of American Society for Quality. And today we're going to have our managed a revolutionary customer-driven product development and production process in an Industry 4.0 platform by Dr. Kai Yang. There we go. So Dr. Kai Yang is our speaker. He's currently a professor in the Department of Industrial and Systems Engineering at Wayne State University. He's got both his master's and PhD degrees from University of Michigan, and he is considered an expert in Lean Six Sigma, quality engineering, and data analytics. Of course, data analytics these days is very important. He's a fellow of the Institute of Industrial and Systems Engineers. He's been awarded the Cecil C. Craig Lifetime Achievement Award in the Automotive Division in 2016, which is a very prestigious award. He's been awarded sponsored quality control projects by our OEMs, General Motors, Ford, and Chrysler, where he and his team had key roles in developing development of quality control software systems for more than 16 assembly plants for Chrysler and GM. He's also been involved in 4 other sponsored projects that's been funded by Siemens, which drastically reduced product development lead time, where you can save millions of dollars in the product. He's been the author of 8 books, and to call out one of his books, Designed for Six Sigma, it provides a framework in order to integrate both innovation and traditional statistical quality assurance methods into the product development process, which then would ensure the end quality would be much higher with the integration than without. Then since 2007, Dr. Yang's been leveraging his statistics and quality engineering expertise in the healthcare systems engineering, which I think there's a whole lot that can be done in that field. There's a lot of synergies there. And he's conducted many training sessions for a variety of companies, including Apple Inc. and Siemens, where hundreds of quality managers and quality engineers have been trained under Dr. Yang. So I will turn everything over to him. I'll be going on mute. If you have any questions, please send them to me in chat. Thank you.
Oh, thank you, Lisa. So I hope the screen, okay, now the screen works. So I'm very happy, very glad to give a webinar here. So today, talk, I have like 5 sections. The first, we talk about Industrial 4.0. So I first go briefly talk about Industrial 4.0 platforms. What is that? What are the one currently in using? Secondly, I'm going to focus one of the Industrial 4.0 platform called the CosmoPlat. So this one is really very new, and it is a good one. It actually really make revolutionary change for product development, the production, everything. So I'm going to give description and how this kind of system work, and what they have achieved in other places. So finally, since this is ASQ, American Society of Quality, and recent 2 years, there's a saying, Quality 4.0. Basically, what they say is the things are changing. So we now, Industrial 4.0 is coming. A lot of things in the quality probably already too old. We need to have some new, new management principle, new practice for quality people. So I want to talk a little bit about that. So then it is question time. So this is my overview. And first of all, is what is Industrial 4.0 platform? So I hope a lot of people already know what is industrial, the fourth, what we call the fourth industrial revolution. So basically is Internet of Things. So basically the Internet, the device can be implemented, embedded in many different places, in the plants, in the product, in all kind of places, Internet of Things, big data, artificial intelligence, quite a few autonomous robots. So those are technology side of Industrial 4.0. The other is Industrial 4.0 ecosystem. So ecosystem, basically, if we look at this chart, it is still the things, especially our automotive people are familiar with. The product development, the production, suppliers, customers, and so on and so forth. So Industrial 4.0 platform, by definition, is the software platform that connect, manage industrial processes in the Industrial 4.0 ecosystem. So this is the definition I put it up. So currently, actually, they are available industrial platforms. So the first, I'm going to quickly introduce two of them, which probably some people are already familiar with. One is GE. They call the Predix. So this is the this is the platform, which actually what they do is managing the industrial facilities, production, plant, and so on. So I'm going to play a short video about GE's Predix platform. So that will give us a good idea how it works.
There's great power in what if. What if you could anticipate problems before they occur? What if you could reduce unplanned downtime? What if every machine, all your equipment, was performing at optimal levels safely and securely? What would that look like? Welcome to GE's Asset Performance Management suite of solutions powered by Predix. GE's cloud platform purpose-built for the unique volume and velocity of industrial data and analytics. Here's how GE APM works. To get started, just get connected. Capture and manage data to gain a more complete and accurate view of your equipment and machines. This first step of the journey monitors machine and equipment health. Next, use advanced analytics to get insights, predict and diagnose issues early, and respond before failure. And these insights can help you make better decisions. This phase is called reliability management. Then, get optimized. Create maintenance strategies that balance reliability, performance, and costs. This is maintenance optimization. GE's Asset Performance Management gives you the tools to get the most value from your industrial scale data and get the right information in the right hands at the right time. Across industries, our customers are seeing results. From oil and gas companies using real-time online condition monitoring to help them avoid potential incidents, to manufacturers consolidating operating data to smooth out process variation, to utilities that are using big data to reduce maintenance costs. Industry leaders face increasingly complex business challenges. You need a partner with industrial experience, deep domain knowledge, and a long history of operational excellence, a digital industrial company. The next industrial revolution has begun. The age of intelligent machines is here. Are you ready? The time is now to get connected, get insights, and get optimized. so you can achieve your goals today and into the future. Asset Performance Management from GE.
Okay, so this is one. So the other is Siemens MindSphere. So actually, this one, in my point of view, is quite similar to what the GE Predix is doing. So probably they can manage more, variety of industrial facilities. So also, I have a short video to display. So I'm not doing marketing for those two companies. So because really the one which I think is better, quite a bit better than these two, is the next. So that one I'm going to do a thorough introduction of that. So let's see what this MindSphere.
Digitization has long been ubiquitous. Billions of devices produce vast amounts of valuable data. However, only a tiny fraction of it is used and intelligently analyzed in the industry. As a comparison, smartphones have just a handful of sensors, while a single industrial motor, for example, already has about 2,000 data points. So there is a large wealth of data, but the question is, how can it be put to good use? The answer is MindSphere. But what exactly is MindSphere? As an operating system for the Internet of Things, with open standards and open interfaces, MindSphere is something of a Swiss Army knife for all connected machines and devices, regardless of the supplier. Their data is selectively collected at configurable intervals on the MindSphere platform, where it is available for further evaluation. The data can now easily be linked and brought into relation with each other in order to obtain new insights that have been unimaginable before. There are apps available for precisely this task in an ever-expanding pool of apps, both from Siemens and third-party suppliers, and, if you want, even from yourself. Companies can optimize their products by evaluating how, where, and under what conditions their product is used. These insights can immediately be fed back into the production and design process to make the product more efficient and more practical. The advantage: you obtain concrete application data from real assets, virtually in real time, and you do not have to resort to generic test data. Cities and entire societies can also profit from MindSphere. Huge amounts of data are generated in the proactive maintenance of trains, the optimization of traffic flows, or with decentralized energy systems. And all these data sets can now be combined with each other and provide completely new insights. With MindSphere, we put that wealth of data to good use. This allows highly innovative business and service models to emerge and has the potential to decisively influence the world of tomorrow.
Okay, very impressive. However, both of these two Industrial 4.0 platform really doesn't engage in one of the most important activity in the Industrial 4.0 ecosystem, which is product development and production. We know somehow they, take information from the production. So, so now I'm going to introduce the next one. So before that, I want to put a few things on the background. One of the things is the customer in current age are very different than 10 years or 20 years ago. So they are totally connected. Everybody has, mobile phone. They can get information. Whatever they check the product, they can know all the competitors, all the price. They have friends. They get a lot of feedbacks. They have social networks. So also the mind, they are changing very fast. So it's a very evolving and difficulty to deal with customers. So this is different than in the past. The other is the customers are more individualized. So this charts actually was the research result of Professor Coran of University of Michigan. So actually you can see like the first this curve is 1850. So that time the people all, almost all the product are individualized, personalized. So the lot size is one. Everyone produce one piece. As the time going, especially like we know the Henry Ford slogan Model T, we only do black color. So we have a very few variety, large quantity. So that's happening 1913 to 1956. So right now, when we follow the curve after 2000, we go to a direction of, personalized production, mass customization. So this is the trend for many products for now. So actually, I'm going to show this new Industrial 4.0 platform actually will make this happen and really, very amazing. It's doing very well. Okay. So the customer Industrial 4.0 also very diverse, very personalized. They expect more. So this, industrial platform, I think in America, probably they don't know a lot. This is relatively unknown. They call the Cosmo plant. But actually, in last 2 years, it gained a lot of attention industry-wide. So it gained the award of 2017 in America. This is a Gartner Supply Chain Innovation Award, very prestigious award. So last year, also this system is connecting the customer, the product development, the factory. So actually, the factory linked to this software get one of the 9 the best factory in the world. So I see some of the results, like we know for flexible production, like setup change, like die change is one indicator. So this factory can do 5 change in 15 seconds. That type of speed, we know Toyota say single minutes die change. So this is like single second die change. So setup change, very flexible. Well, this is like one of the best factory in the world that is connected to this type of platform. Actually, the developer of this platform is Haier Group. It's a Chinese company, so probably a lot of people don't know in here. This is actually the largest appliance company in the world. And it also owns different franchise, like even GE Appliance is part of Haier company. So just let you know who developed this, what type of industry it's working with. Then what is the motivation for this platform? So basically, the motivation is, as what we said, the customer Industrial 4.0 is connected, well-informed. They have their ecosystem when they buy a product, and even now, many more products become connected, like appliance, cars, many equipment, the mobile phone getting connected. So they use their product going all the experience, like for example, refrigerator, they buy food, they, like this refrigerator is internet enabled, they can scan what food inside, they can tell you when they expire, they can actually give you recipe, and actually you can even order the new food from the touch screen. So so you have an ecosystem on the customer. Then the other thing is we know product development, you have their ecosystem, their system. So the motivation is why we not make industrial platform which connect these two ecosystems. So in this way, like first of all, with the help of Industrial 4.0 ecosystem, we can, we can find out what the customer need to make a, design and produce a product to satisfy personalized need. Also, when customer using their product, they derive additional need, additional demand. So you can also satisfy with different product or adding services and so on. So in this way, you can increase your revenue. So that's the idea, to make a platform connect everything all together. So so this case, in this platform, actually they have connected, the user community is connected. Also, with digital touch from the appliance, from mobile phone, from computer, then they can connect to the whole product development cycle. So from order, they can see, when you have customized order, how that goes through the production and shipment. So that's the idea. That's the idea. So the three things connected, like connected process. So not only the production, but also product development, suppliers, and the technical developers, and so on. Then user community also, you have ecosystem and so on. So this is the idea. So, specifically, this slide shows, the whole things, how this platform, how they connected to the customers, to the device, to the product. Also, tracking, also the whole production process, also the product development. So the information, digital touch, all the things, you can see they go through, you actually run through everything. So also that is a fundamental platform for running the product development and also production. So so this is give you a visual how it works. Okay, so in this way, so when you have this type of idea, to deal with, the customers in Industrial 4.0, so not only you need to have technological change, in this company, they also do an organization change. So that is also very amazing. That is also very amazing. In traditional company, we have our pyramid structure. Your top, middle, also the lower level employees. So they already transformed their organization to to many connected micro enterprise platform. So which I'm going to describe in detail. Also, like so for the functional department, for functional arm of the company, for example, research development, supply chain, and logistic, that's also become so-called different type of enterprise or platform. So I want, because I'm university faculty, I want to give a similar example how, I think somehow it is similar to how the university professor works, especially they are doing research. So every professor is an entrepreneur. They're looking for research opportunity, funding, who has the money, who, where you can get it. They run as an enterprise. The university is like supporting platform. You need to pay money to the university, but the university also give you different support. That's thing. But you are self-managing entrepreneur. Okay. So this organization change, I call it a dynamic micro entrepreneur ecosystem. The advantage for product development is they are faster, they are very flexible, much more flexible than traditional organization. For example, in the left side of this organization chart, like a pyramid. So the top is the manager, then you have middle layers, then you have employee. That's the way it works for many companies. So for this company, the first they have, first like all, in our case, is a product development team. They all become micro entrepreneur. They directly face the customer group. So they make their own decisions. They find their own market. They define their own new product. So the first is like a reverse pyramid, like the bottom is providing support. But that is only the first, version 1 of this dynamic micro entrepreneur system. So that, you can refer to the very recent December Harvard Business Review. They have a very good article for this system. So actually, because the connection is through this internet information network, so actually we know everyone can be connected to everyone directly. Why we need this hierarchy of organization? So currently they have version 2. They have a version 2. Actually, is everyone can be connected to everyone. So you can see this chart, like the bigger one in the, the bigger one in the center. ME is a market-facing enterprise. So for example, I'm doing the air conditioning. Then you have relation with some people in sales, some people in support, some people in production, some people in design. Not everyone. You can connect to the one which is relevant to you. So then you do your autonomous decision making. So the organization model that's mimic the internet, so-called small pieces, join loosely. You can connect, reconnect, deconnect with whatever necessary. Also, you are not limited within your organization. You can contracting, you can working with other business entities. So flexible, coherent with little central direction. So basically the motivation is the employee are entrepreneur. And if you can get more business, more sales, better product, then you make more money. You share some of your revenue with the company. The company also support you with their system, brand name, and so on, the other platforms. So this one, they make the product development team much more powerful, much more autonomous, and quick reaction to market change. So that also, I think, is a necessary part, a very important part of this system. Okay, so that is organization changes. So the other is, so now I'm starting to give you a couple examples how this system works in designing a particular product. Give you a couple examples. So this product development process, because it is appliance, may not be exactly the same as automotive. So it use we call, like I call it fully connected agile development. So we know, like in automotive, is different because automotive, like usually we have a slogan like "Do things right the first time." Do things right the first time. We also call slowly success. So like we first do like body, then we do slowly, but we're going to try to make it better and better. That's one thing. So for this one, agile development basically say you get your idea from lead users, from observation of customers or technology driven, the new technology. Then you link to a design team like design resource, R&D, and also they call solution providers. So they have like a iterative design. So you quick do a design, then experience by some the team, especially the customers. So they basically the customer, the users involved in the whole product development cycle. So from the beginning, from the concept to the end. I think this is quite different. So this way you can get, try out, get feedback, get a problem, sort things out very fast. Okay. So I gave two cases. The first case is self-cleaning air conditioning unit. So this motivation is the AC for special type of customer, like the pregnant ladies with kids are very, like they don't want to blow hard wind. They want a clean, low noise, and also the AC can self-cleaning. So they got this idea from, the customer need. Also, you can see this cycle. The first, they have like quite a few number of customers deeply involved in design because they want to provide a personalized product. We know modular design is one way of provide your service in high flexible fashion. So they also call the modular suppliers. So then by doing those design, they have seven major function, 5 design iterations, design iterations. Then you have the first 11,000 sales, from different channel. Then you do the production. So this is just the first iteration. So when you have the product, then the product is IoT enabled. So a lot of usage data get back to the company. Also, the people who involved, they have customer themselves. The information get back to the company. Then you have next round. next round of, the first is a smaller batch. The second is much bigger, bigger batch. But you have a huge number of improvement. This also because this platform, the create an environment which you can get a lot of things to do in parallel. You can get a lot of people, maybe looks like, quickly get to the right place, contributing their idea and get things done. Okay. So the second round, what you can see is, they get a lot more improvement, getting much quieter, self-cleaning gets better, and So also the other thing is, in this system also you have big data and artificial intelligence, like the unit you produce and ship to the customer. You monitor real, noise level, the air quality level, and actually, like, you can push if you find something not right, like some of the noise you never thought it will happen. You can push in the new program using AI to depress the noise, so you make that go away. You have huge amount of manufacturing data, monitor, collected, analyzed. Also, usage data get back. Also, the customer data from user social network get back. So your quick improvement. So this is the case number one. Also, the other case, the product development can be the customer need driven. It also can be technology driven. So later I also say this a platform also linked to a huge technology provider network. So new technology also can drive innovation, drive new product. So this way, because everything is connected, then this product is one type of refrigerator we call wet and dry storage. So what that means is, we know in refrigerator, if you put fruit, fresh vegetables, when you put a long time, it's getting dry, it's getting, not so good. When you put really the things should be dry in the refrigerator, they're getting moist, they're getting wet. So this refrigerator supposedly they can keep the wet thing wet, dry thing dry. So that's the idea. They have a few good technology from different provider, university and other place. So also they are personalized. What you can see is by interact with the customer, actually you can add features, you can add things the people like. Actually, you can sell in a higher price. You can sell in higher price. So this way, we can increase the customer value for that. So this is basically also you can personalize for different people, different type of things. You do different variation. So this is another case study. I also know, like in Harvard Business Review, they also have some people, when they see unusual customer need, for example, they are doing for example, one of the product is washing machine, but somehow one of the customer put the potato, put the vegetable in the washing machine. Then they say the washing machine doesn't work. So then they complain. But the people who find this actually think, even though this is wrong usage of the product, but probably you can develop a whole different bunches of products. It's like selling, washing machine for vegetables for small restaurant owners. You actually open a whole set of new business. So from those. So because you have this flexible organization structure, so there are lots of room for innovation, the new product from all the venues. Okay. So also in this way, like they have incentive. They have incentive for customers. Like if customer involved in contributing the design, you can get I don't know exactly how, but maybe free product, maybe some benefit. Also, like it's not only open to the design process, not only open to the designer within the company, also outside, like technical provider. One of the example is they are doing a washing machine lines. One of the customer complaint is one of the bolt, one of the things easily get a rust because they have not a bolt. Then one of the German suppliers says, I can design the same thing without even using one bolt, one fastener. So then the proposal taken, then actually the thing getting, you can sell for higher price and people like it. So yeah, so this is like how you're going to reward the people who contributed. So I also show some of the what kind of thing they got from this process, like what the customer input. This is kind of like posting in their sites, in their things. What the customer posts, all kind of things. So this is your voice to customer. Maybe thousands, meaningful things like that, pieces like that. Also, like because you open the design for wider designer selection. When you need design, you also get from all kinds of sources, different idea, different artistic design, different technology, things like that. So just to show you, what type of interaction we have. This one has in this platform. Okay. Okay. Then one other thing I think is also very important to increase the effectiveness of this, this system, which is their technology provider. So they call it HOPE. Basically, what that means is they base the idea on open innovation. So-called open innovation is you have your internal technology base. Also, you have external technology base. So some of them are full-time, some are standby. You're contributing to your own company's purpose. Also, you can sell your technology, provide technology to others. So that's what they call the open innovation. So there are many innovators live on it, may not be full-time, but whenever there's a new project, when the people find it fits, they can join in. Then also this system, not only you look for the right technology, also you look for marketing trend. What is the customer's pinpoints? Field observation, what are possible business new ideas? So they have created a whole network of 400,000 called technology solvers. They call it technology solvers. So this so-called technology provider, part of them is internally, like 10 R&D centers. So they have their, that's internal source in different places of the globe. Also, there are people who, stand by. They know they can work anytime as fit, as things fit. Okay, so they all connect to this Industrial 4.0 platform. So the type of technology solver can be many different kinds, like some research company, other companies, and also like in the US, I find one thing which I know they call the Nine Sigma. This Nine Sigma basically is a company who go to all kind of company looking for what type of technology the people wants, in those companies. Then getting this idea, they send the people they know asking for proposals. If you have the right idea, you write a good proposal, then you have they give you money to develop technology, then they're going to buy your technology, sell to the company, a lot of different things in there. So this is a huge. So in this way, they get the right technology, and they have a huge basis, because when you have different customer need, then you need to say how to do it. So that's how they can jump in and provide that. So this Industrial 4.0 system, actually, even by the end of 2017, they already become a working system. You get like 15 billion US worth of orders, 41 million items go through the system. And so this is the world's largest mass customization platform. So this is it's already there. It's already working. Okay. All right. So this is a description of CosmoPlat. So I want to have a few some summary of this and some thought about the quality. So one is this product development system. It is quite very different. I think very different than the product development system which we saw in the past. So you have customers deeply involved. You have micro enterprise, the team which really interact very well with the product development and production very well. And also, we know like the new product development, you can't say listen to customer. Also, another arm is innovation, technology driven. So they also have very strong arm, so-called hope, this type of a platform on that. Also, they can integrate very easily because you have the platform. I know Professor Jeff Liker, he write a lot of books on lean product development. One of the idea he admire a lot in Japanese Toyota is like Obaya, big room. But this CosmoPlat is a virtual infinite room. You can integrate the different people on time, anytime, right on. It's a virtual, electronic, platform. Okay. So one is when the customer getting involved, so we actually can create more value. So because usually when we, the traditional product design, so the customer doesn't see when they actually use it. When they use it, you already face everything. Even, you know a lot of things. You can increase your value. You can add this to increase value. You can't do that anymore. So this way you can from the beginning to add value. I saw some of them you can even sell for higher price. Okay. So other is the concurrent engineering go to extreme, massive parallel go to extreme. So so this is really impressive. So also little waste because a lot of things happen simultaneously. You do not say I do something, to hand up to other department that other department don't know what you are doing. So with this platform, you can fully track also the things, communicate in real time. So as the result, I talk to them, say, when you have this platform, what type of customization you can accomplish. So what they say is like 16% they call user individualization. What that means is maybe even their picture, their image, their logo, their own color are printed, are made in the unit. Okay. Second is modular customization. This is similar to what we order laptop. You click buttons, you choose, click buttons, what you want to add in, what you don't on PC. So that's a modular customization. So the last two example is actually we called customer co-creation. So customer working with the designer to create some brand new type of innovative product. This accounts for 32%. So if we compare the charts on the right, you can see what actually the mass customization. So you have a different type of product, some fully individualized, some are not. This is already happening. Okay. Also, so this platform, whatever the predicts GE Siemens, you get the information, you feed that information, preventative maintenance, predictive maintenance, they can all do that. Also feeding the information for continuous improvement. So that all this, it can be done. Okay. So this is the other takeaway. So what kind of effects it already achieved. The other is obviously achieve great result, like product development, the lead time, for example. I heard like usually the similar product other people do, other company take 1 year for designing the product. For them, only like 3 months. So about huge improvement. For them before maybe 6 months. After this now like 3 months. Okay. So very, very big improvement on a lot of key metrics. Okay. So the last a few thoughts is about the quality. So I presented this to last year in Dallas in one of the conference called the Quality 4.0. So very interesting because people think with all this new technology, the current quality stuff, quality management was developed 50 years ago, 70 years ago. Maybe it's time to change now. So there are a lot of new reality with Industrial 4.0. Actually, I buy into this, but how to change, we don't know. So like people, machine, data are connected, a lot of them, okay? So also like AI, IT, Internet of Things embedded in traditional product. I know automotive, because of this, they actually increase the problem of quality control, you know, the problems. So also some powerful tools, cloud computing, deep learning, artificial intelligence. So also the extreme accuracy machines, extreme automation, also traceability, transparency of the process of data. A lot of these things doesn't exist in 20 years ago. So new realities. Then, so in this case, how we're going to change? What we're going to change? Industrial 4.0. So first of all, that is my opinion. So like, even though we call quality satisfy customer, good customer experience, so on and so forth, but we never had really a good way of doing this. So, for example, finally, the people who are working on quality always working on reducing defects, you know, increase compliance, conformance. So we know, like, one of the quality is performance quality. So you design a better product, you sell more money, people want to buy it, they're more satisfied, you get more. Then we don't have any way of managing and doing that. So probably by Industrial 4.0, I think that's actually at least as important as conformance quality. So which we can't do in the past. Okay. You see Six Sigma, that's about the defects. TQM, PPM, that's the defects. Okay. Also, who is doing the quality? So you know, people say IT people maybe play a bigger role. Of course, product development team play a bigger role, and maybe others. So that's open for discussion. The other thing is the methodology and the tool for quality. So, for example, you know, in those examples, currently there are millions of online nodes. You can mine VOC. So, are we still using QFD for that? So that's a question, right? That's a question. So, like a different way we are getting the customer voice of customer. So, should we have some new things to work on instead of old stuff? So also like right now in some of the very good plans, you know, if we want, we can get all the data, even the image. So are we still stick to STC as usual? Can we, you know, maybe we do some other things? Another thing is, even though some people may say, even though we have lots of data, but lots of data are wrong, lots of data are garbage. So this one, I think actually the data calibration, which it says is data reflect reality, data quality, that's become more important, quite important for us. Also like quality assurance for embedded product, traditional with IoT with others. What is a good way to do that? Predictive quality, also like compliance, risk management in digital age. See, like I'm working with healthcare as well. We know why U.S. healthcare is so expensive. Many reasons. One of the reasons is how do you deal with compliance, risk management, lawsuit, and also we know the U.S. the pharmaceutical things are very expensive, drug very expensive. You're going to go through the FDA stuff. So that all the system was developed many years ago. With the digital age, can we do better? So yeah, many things. We think probably that's something we can think about. If we have new quality, that's some of the things we should think about. And the other thing is massive data with, how do we use data for rapid continual improvement? So the other thing is a quality management system. So we have old school, but a lot of new things are coming. Are we still doing those ineffective, very slow stuff in quality management? The last thing is when I show this stuff to some of expert, some people say, "Oh, we need to add in the quality stuff in those platforms." So that's also one of the thoughts. But anyway, those are open questions for this. So the last few minutes, I'm going to summarize by showing the video for this new system.
Hire's Cosmo is a world-class innovation, first industrial internet platform that introduces users to participate and experience in the entire process. As intelligent manufacturing becomes a symbol of the new industrial revolution, IT, AI, and other technologies have gradually integrated with the manufacturing industry, with the emerging new production modes, industrial forms, business models, and economic growth. Hire's Cosmo has provided completely new thinking for global industries and incorporated users into the overall process of the industrial system. Hire Cosmo is at an industrial internet ecosystem platform different from Germany's Industry 4.0 and Industrial Internet of America. The core of Cosmo is a mass customization mode focused on user experiences. Hire is not simply replacing people with machines, but the essence is to connect with the user. High efficiency under high efficiency guidance, precisely focusing on all users' needs and weak points to meet their optimal experience via the application of the full process, paralleling nodes of the artificial intelligence. Cosmo is not simply providing industrial products, but the services program for a better life, which achieves the extension from the product cycle to the full life cycle of the user. Meanwhile, the big data of Cosmo meets the user's demand for small data so as to achieve the endless cycle of iterations. Cosmo have the world first-class resources allocation, which will assist enterprises worldwide in the intelligent upgrade and build a future leading intelligent manufacturing mode. Linked to the ecology via Cosmo. Every enterprise, resource party, and user under the open platform, Cosmo, can innovate, win, share, and create the best life experience together. Has undergone Hire's internal practice verification and model precipitation, and has built up 10 full process interconnected factory. Achieves every product, have unique order information, and delivers the customer's needs directly to the factory. The global resources allocation of the platform. Achieve 7 functional modular to implement and apply in Linji, Chantal, Ocala, leading and comprehensive, which breaks down industrial and cultural barriers and leads global enterprises to make the manufacturing transformation and upgrade faster, better, and more efficient, and become the eco-brand of the leading intelligent manufacturing trend.
Is the ability for companies like Hire to use platforms like Cosmo Cloud. And this is the future of smart manufacturing.
When people imagine the future has actually emerged quietly. When people marvel at technologies, They have been melted into life already. Cosmo will make enterprises more intelligent, intelligence, more imagination, and a better life.
Okay, so that's my presentation. So